When you look up at the night sky, you're not just looking at shining stars and planets, you're looking at a system that we believe we completely understand. Since childhood, we've been taught that the solar system works like a well-organized machine. Every planet has a fixed path, a fixed role, and gravity keeps everything under control. That's why, when we look at space, it gives us a sense of comfort. But there's one uncomfortable truth in the history of science. Whenever a system starts to feel completely understood, the universe gets ready to surprise us. The story of Planet X begins at exactly that moment. It started with a single doubt that slowly turned into a scientific obsession. The problem wasn't that a planet was missing from our view. The problem was that the planets we could clearly see weren't behaving the way they were supposed to. Massive gas giants like Uranus and Neptune were showing a small wobble in their orbits. The wobble was so tiny that a normal observation could easily miss it, but it was consistent enough to be detected through mathematics. The equations of physics kept repeating the same message. There's some extra mass out there, something we can't see, but whose gravity is slightly shifting everything around it. And in science, when the numbers keep telling the same story over and over again, ignoring them becomes impossible. This is where the story's internal conflict begins. If the solar system isn't behaving the way it should, does that mean we've misunderstood it from the very beginning? This wasn't just a question about a missing planet, it was a question about our certainty. Humans naturally believe that whatever they can see is the truth, but the idea of Planet X challenges that belief. Maybe we're only seeing what is easy for us to see, while everything else is hidden in the darkness. And for science, that's one of the most uncomfortable ideas. This is where science steps in, like a guide. Science doesn't panic. Science doesn't play the blame game. Science follows one simple rule: bring the data. Astronomers refined their calculations, built new telescopes, and spent decades comparing photographs of the night sky. This wasn't a dramatic race, it was a story of patience. Every night the sky was scanned. Every night another observation was recorded. Then, in 1930, a discovery was made: Pluto. The whole world celebrated. People believed that Planet X had finally been found. Headlines were written, textbooks started being updated, and people assumed that our solar system was finally complete. But science doesn't run on celebration alone. When Pluto's mass was calculated accurately, an awkward silence followed. Pluto was far too small to explain the wobble of Neptune and Uranus. That meant the original problem was still there. Planet X was still missing. Pluto was an important discovery, but it turned out to be the answer to the wrong question. At that point, some scientists suggested that maybe the original calculations had been wrong. Maybe Planet X never existed at all. Maybe it was all just human error. But in science, maybe means one thing: test it further. For a while, the idea of Planet X faded into the background because technology was limited. Observing the outer solar system was extremely difficult. But as scientific instruments became more advanced, the story came back into the spotlight. After the year 2000, when astronomers started focusing more on the edge of the solar system, the most distant objects in the Kuiper Belt began getting attention. This is the region where sunlight is almost gone, and objects take thousands of years to complete their movement around the sun. It was here that astronomers discovered several celestial objects whose orbits should have been completely random according to theory. But when their data was analysed, a strange pattern appeared. Even though these objects were far apart, their orbits were all pointing in a similar direction, That looked far too organized to be just a coincidence. It was almost as if something unseen was controlling them without ever revealing itself. These were the same kind of gravitational footprints that had first been noticed in the wobbles of Uranus and Neptune. The difference was that this time the stage was much bigger. It was at this exact moment that the idea of Planet X evolved. It was no longer just a missing planet. It could now be a hypothetical giant world. It could be so far away that seeing it directly is extremely difficult, and so massive that its gravity affects the entire outer solar system. This updated idea was given a new name, Planet 9. Scientists proposed the hypothesis that this planet could be several times larger than Earth, and its orbit could be so enormous that it would take thousands of years to complete just one trip around the Sun. Just imagine this. While humanity was building cities and writing history, Planet 9 may have completed only a tiny part of its orbit. At this point, the story reaches a clear decision. One path says to treat all of this as a coincidence. It says this is just observational bias, that we're only seeing patterns because we're looking in certain places. But the other path says to take the evidence seriously and accept that there could be something at the edge of the solar system that has escaped our view. And, as expected, science chose the second path. Because science doesn't choose what makes us feel comfortable. Science chooses to follow the truth, even when that truth is inconvenient. This is where the stakes become clear. If Planet 9 exists, then our solar system is not a closed, stable system. It's dynamic, unpredictable, and still evolving. And if Planet 9 doesn't exist, then it means our understanding of gravity is still incomplete. Either way, the outcome is powerful. We will either discover a new world or discover a mistake in our own understanding. And for science, both outcomes are progress, not failure. In the middle of this story, another complication appeared. The internet and conspiracy culture hijacked the name Planet X. Claims about rogue planets, collisions with Earth, and end-of-the-world predictions started going viral. But this is where science draws a clear line. This is not a story about an apocalypse. It's a story about slow, patient, and sometimes boring orbital mechanics. It's not a story about headlines. It's a story about calculations. Because science doesn't run on sensationalism. It runs on evidence. So, what does success really mean? Success doesn't mean that Planet 9 suddenly appears in a telescope tomorrow morning. Success means that we're not turning away from the unknown. And if Planet 9 is discovered one day, it won't just be a tiny dot in an image. It will be proof that the universe is more complex than we imagined, and that we're still in the early stages of understanding it. And if Planet 9 is never found, we still don't lose, because we'll have learned that science doesn't promise certainty. Science promises honesty. Planet X may turn out to be a real planet, or it may simply be a mistaken assumption. But its story clearly proves one thing: the universe is not silent. We're just slowly learning how to understand its language. So, if you enjoyed this video, make sure to like and share it, and subscribe to the channel for more videos like this. But wait, what if every human on Earth suddenly disappeared tomorrow? Would nature reclaim everything, or would our civilization's traces survive for millions of years? The answer is in the video on your screen. I'll see you there.